we wrote 2 chapters on maintenance and additive manufacturing. These essays aim to show the importance of maintenance in the industry, how maintenance evolved over time, and how additive manufacturing can be used to improve maintenance. In the manufacturing industry, maintenance has the role of keeping physical assets in a condition good enough to achieve the target quality of the end product. Say that we are a manufacturer of glass bottles. The geometry of the bottle is of paramount importance to ensure its closure and the correct preservation of its content. Assume that the content is spark wine. A minimal defect in the bottle could cause its break, hence the loss of its precious content. Therefore, the dies from which the bottles are forged must be maintained in perfect conditions. They must be refurbished and changed frequently in order to avoid a poor quality of the final product. An intervention aimed at keeping the production machines in their best condition is called preventive maintenance, and in the scientific literature, the debate on how to balance the cost of corrective maintenance and preventive maintenance lasts from decades. In the chapter Maintenance Management in Light of Manufacturing 4.0, we summarize the evolution of maintenance modeling up to the most recent advancements. For instance, one of the most cutting-edge technologies in maintenance management is the concept of digital twin. This foresees that physical systems to be coupled with a digital counterpart, which exploit data to produce advanced simulations and analysis. Among the main goals of a digital twin, there is the ability to estimate the remaining useful life of a system. That is, the number of hours, days, or weeks that the system can operate before entering in a degraded state. If digital twins seem something very futuristic, you must know that they are already in use in the aerospace industry. By the way, we think that another technology shows the potential to change the way in which maintenance is carried out today. I'm talking about additive manufacturing. In the book, we describe an application of additive manufacturing to a metal forming process. The dies used in the process inevitably wear out when they are used for a long time. Therefore, they need to be refurbished. The process is usually made by hand, but nowadays it can be performed through the combination of subtractive and additive manufacturing. The most worn parts of the mold are removed by machining, and subsequently a new surface is printed using additive manufacturing. This allows to waste less material during the refurbishment process, to obtain a mold geometry closer to the nominal one, and to perform the repair faster. Furthermore, in the book we discuss how the use of additive manufacturing could give rise to new business opportunities in the maintenance field.